Good evening, boys and girls. Let us go through our formative test together. Now, our formative test starts with question 7. It was picked from one of the previous exams. Question 7.1, the examiner asked you to complete the line of the first theorem. The theorem states that the line from the center of the circle to the midpoint of the chord, you need to complete this. So what does that theorem say? A line drawn from the center of the circle to the midpoint of the chord, it is perpendicular to the chord. Now some of you says it bisects the chord. Already they are telling you it goes to the midpoint of the chord. That means the chord has been bisected. So you cannot say a line that is drawn from the center of the circle to the midpoint of the chord, it bisects the chord. It is perpendicular to the chord. So that line, it is perpendicular to the chord. So that is what you were supposed to write. Let's look at 7.2. 7.2, they said, write the converse of this theorem. Now, the converse of this theorem says a line drawn from the center of the circle, perpendicular to the chord, it bisects the chord. So some of you are repeating the given theorem, but they are saying write the converse of it. So it is the line drawn from the center of the circle, perpendicular to the chord, it bisects the chord. So we say a line drawn from the center of the circle, perpendicular to the chord, it bisects the chord. So in question 7.3, they say AB is the diameter of the circle O. So O is the center of the circle. They say OD is drawn parallel to the chord BC. So we can see it is marked here that these two lines, they are parallel. So the radius, the length of AO is 10 centimeters. The length of OB is 10 centimeters. Therefore, the length of AC, it is 16 centimeters. All this length, they are given in centimeters. Now, the first question says, prove that the length AE is equals to EC. In other words, the question wants you to prove that this line AE is equals to EC here. So, what theorem can you use to answer this question? Many of you got this wrong because you tried to use the theorem that is given in this question. Theorem number 1, which says a line drawn from the center to the midpoint of the chord, it is perpendicular. Now, you are not told that E is the midpoint. You are asked to prove that E is the midpoint. So that theorem falls out. Secondly, the converse of that theorem says a line drawn from the center perpendicular to the chord, it bisects the chord. Now this line is not perpendicular. Instead, it is parallel to the other side. Now what theorems have you learned that talks about a line being parallel to the other in a triangle? In grade 10, you learned about the theorem called the midpoint theorem and its converse. If I've got triangle ABC here, and we've got a point here, I'll call this point M, and point here, I'll call it point N. And there is a line joining these 2 points. If point M is the midpoint of the line AB, and N is the midpoint of the line NC, therefore the midpoint theorem says, therefore the line the line MN, it is parallel to the line BC. So MN is parallel to the line BC. And therefore it further says that the length of MN is equals to half of the length of BC. And when you have applied this theorem, you simply write midpoint theorem as your reason. So, can this apply in this case? Not really. What I know is that the point O is the midpoint of the line AB because O is the center and AB is a diameter. Hence, it is marked that OA is equals to OB. But AE is not equal to EC. That is what we need to prove. But what does the converse of the midpoint theorem says? Let us look at this triangle. So the converse of midpoint theorem says, if there is a line going through the midpoint of a side of a triangle parallel to the other side, it bisects the third side. So what that means is that this line that is passing through the midpoint of PQ, it will automatically bisect the third side of this triangle, which is PR. Therefore, this line here will be equal to this. Let me call this point here T. Therefore, PT is equals to TR. Therefore, if I look at the diagram that is given, it satisfies the condition for the converse of the midpoint theorem. We've got a line that is passing through the midpoint of one side of a triangle. I'm looking at triangle ABC. There is a line passing through the midpoint of the line AB parallel to the line BC. Therefore, it should bisect the third side. So the reason that I'm going to write here, I simply say AE is equals to EC. Why? It is a line through the midpoint of a side parallel to the second side. Or you can simply write converse of midpoint theorem. Why? Because the line OE is parallel to the line BC and O is the midpoint of AB. Therefore, E should be the midpoint of EC. Right? The first approach of answering this question. There are many other ways which you can also solve this problem. I saw some learners, they also apply the proportionality theorem. Remember the proportionality theorem that we just did, what it says. If there is a line parallel to one side of a triangle, that line, it divided the other two sides in the same proportion or in the same ratio. Some of you went to the extent of finding the value of AE and finding the value of EC and show that they are equal, and that is also acceptable. Again, there are many ways. One, we need to find the size of angle C. Now, angle C, it is subtended by the diameter AB. So you remember that the angle that is subtended by the diameter, the circumference of the circle, is 90 degrees. So you simply say angle C is equals to 90 degrees, and the reason is this is the angle in a semicircle. Angle in a semicircle. That is one of the theorems that you learned in grade 11. Now, if angle C is 90 degrees and the line OD is parallel to the line BC, therefore E1 is equals to 90 degrees. This is corresponding angles. Now, they are corresponding because they're equal because OD is parallel to BC. Now, the last question, 7.3, they say hence calculate the length of ED. Now, look at where ED is. ED is this line ED is this line by the radius OD. So how can we find OD? We know the radius is 10. That means the whole length of OD is 10. What we need to find is the length of OE so that we can subtract it from 10. So we already found that angle E1 is 90 degrees. Therefore, triangle AOE is a right-angled triangle. Therefore, we can use Pythagoras to determine the length of OE. AO squared is equals to AE squared plus OE squared. Now, OA is 10 is equals to AE. What is the length of AE? Since you know E is the midpoint and you were told AC is 16, therefore AE is 8 squared. This is equals to, this is, it's plus AE squared. And then you make AE the subject. So this will be AE is equals to 100 minus 64. And the answer will be 36. Therefore, the square root of 36 will be 6. Therefore, AE is equals to 6 centimeters. Now, if AE is 6 centimeters, but OED is 10 centimeters, therefore, ED is equals to 10 minus 6, which is 4 centimeters. So that is the length of EC. We need to prove that angle BTR, this angle here, angle BTR is equals to angle A. Now, if you don't remember the necessary construction that you need to make here, you are not going to be able to prove this theorem. So remember, you have to construct a diameter through the point of contact with the tangent. Now, here is the diameter. I'll call the point of this diameter the circumference. Let us call it a P. Now, it is your choice. You can either join PA, or you can join PB. So I'll look at both the options. Let's start by joining PA. Now there is an angle that is formed here. I'm going to call this angle A1 and angle A2. The angle that we are looking at here is BTR, is angle T1 and angle T2. Now, what do we say? We know that the relationship between the radius and the tangent at the point of contact with the circle, they make 90 degrees. So these two angles here, they make 90 degrees. So you simply say angle T1 plus angle T2 is equals to 90 degrees. What is the reason? Its tangent is perpendicular to radius. We usually call that tan right. The next one is angle A1 plus angle A2 is equals to 90 degrees. Now this is angle in a semicircle. This is an angle subtended by the diameter, the circumference of the circle. Therefore, angle T1 plus T2 is equals to angle A1 plus angle A2. Why? Because they both equals to 90 degrees. But what do we know? We know that angle A1 is equals to angle T2. These are angles in the same segment of the circle. Angles in the same seg. Now, if angle A1 is equals to A2, is equal to T2, so angle A1 is equals to angle T2. Therefore, angle T1 is equals to angle A2. And this is what we needed to prove, that angle T1 here is equals to angle A2. That is the other option that we can use. Let angle T1 be x. So angle T1 is x. Now, if angle T1 is x, what then is the size of angle T2? Because T1 and T2, they make 90 degrees. So that means angle T2 is 90 minus x. Now, in the triangle PTB is a right angle triangle. Therefore, angle B is 90 degrees. So angle TPB and angle T2, they should add up to 90 degrees. So if angle T2 is 90 minus x, therefore angle P1, it should be x. So what is the size of angle A2? Angle A2 is in the same segment with angle TPB. So you simply say angle A2 is equals to angle x. Therefore, that is angles in the same segment. And following that, you would have answered this question. The length Vy is equals to the length Vn. These are tangents from a common point outside the circle. Therefore, making triangle VYN an isosceles triangle. Therefore, angle N1 is equals to angle Y3. Right? Now, since we are told that they are tangent, that means angle A is equal to all those angles. And therefore, we can also see that they said the length SV is parallel to the length AN. Therefore, angle S1 is also equals to angle A. It is corresponding angles. The first angle that I'm going to write is angle S1 is also equals to angle A, which is 65 degrees. And what is the reason? These are corresponding angles because the line SV is parallel to the line AN. So that is what we write. Which other angle is equals to A? The other angle is angle N1. Angle N1 is equals to angle A, which is 65 degrees. And the reason is this is tan chord. And the other angle, it is angle Y3. Angle Y3 is equals to angle A, which is equals to 65 degrees. That is also by tan chord. Or you can use the fact that Y3 and N1, they are opposite. Y3 is equals to N1. These are angles opposite equal sides of a triangle. So that is another reason that can be used. Now, so this is the diagram that they say we must prove that it is a cyclic quad. Well, if you check angle S1, it is equals to angle N1. And these two angles, they are both subtended by the same line, the line Vy on the same side. So this is the converse theorem of the theorem that says angles in the same segment are equal. The converse says if a line segment subtend equal angles on the same side of that line, therefore all the 4 points are concyclic. Therefore, we can claim that this is a cyclic quad. So let's see how we're going to write that. I simply say angle S1 is equals to angle N1. Why? This was proven. It was proven in 8.2.1. Therefore, angle, the diagram SYVN is cyclic quad. Why? The reason is equal angles on the same side of a line segment or of a line. Or you can write converse, angles in the same segment. Now, let's look at the next question. Prove that triangle ASN is isosceles. Now, they want you to prove that triangle ASN, this triangle here, ASN, it is an isosceles triangle. Now, in order for us to prove that, we just need to find two angles that are equal in this triangle. One, we know that the diagram or the quadrilateral SYVN is a cyclic quad. So let's just remind ourselves. We know that angle S1 is 65 degrees. Angle Y3 is 65 degrees. Angle N1 is 65 degrees. And we also prove that SYVN is a cyclic quad. That means all angles in the same segment are equal. But angle S2 is in the same segment as angle Y3. So angle S2 is also 65 degrees. Now, if angle S2 is 65 degrees, now look at this angle. Angle NSY, it is the exterior angle of triangle ANS. Now, what is the size of angle NSY? The size of angle NSY is 130 degrees. So we will be able to express that. So let me write it here on the side. That is question 8.2.3. I simply say angle S2 is equals to 65 degrees. These are angles in the same segment. These are angles in the same segment with angle Y3. Therefore, I now say angle NSY is equals to angle A plus angle N3. This is exterior angle of a triangle. Exterior angle of triangle exterior angle of triangle NSY. So that means this is 130 degrees is equals to 65 degrees plus angle N3. Now, you're simply going to transpose the 65 degrees. Therefore, angle N3 is equal to 130 minus 65 is 65 degrees. So angle N3 is 65 degrees. So if angle N3 is 65 degrees and angle A is 65 degrees, therefore this triangle is isosceles triangle. You can also claim that the side AS is equal to the side NS. So AS is equals to the side NS. Why? These are sides opposite equal angles in a triangle. So that triangle is isosceles triangle. Question 9. We are told that ABC is a parallelogram. So if this is a parallelogram, that means the line AB is parallel and equal to the line CD. The line BC is parallel and equals to the line AD. Is parallel and equal to the line AD. And what are other properties of a parallelogram? Diagonals of a parallelogram, they bisect each other. That means the line GC is equals the line GA. Now let's see. They said the length CG is 72 units. So CG is 72 units. Therefore GA is also 72 units. They say DF is 24 units. So DF is 24 units and FA is 40 units. Now they say determine with reasons the length of GH. So let us go and look at GH, where it is. So GH, it is this side here. GH is this length here in triangle AGD. But when you look at triangle ADG, they told us that HF is parallel to GC. It is marked here that these two lines are parallel. Therefore, we can apply proportionality theorem here. Well, since we know that the whole length of AG is 72, and we are looking for HG, and we have the whole length on the other side where the lines are parallel, and therefore we also have that. So we can express our proportionality ratio in this format. GH to GA is equals to FD to DA, and you simply write the line parallel one side of a triangle, or you can write proportionality theorem. So this is GH over 72 is equals to FD is 24 over 64. So this is GH is equals to 24 over 64 multiplied by 72. And therefore, our answer is 27. So we say is 24 divided by 64 times 72. And the answer is 27. So the length of GH is 27. And therefore you can minus 27 from 72 and you get 45. That means the length HA is 45 units. Now when you look at 9.2, they want us to find the value of the ratio of the areas of triangles. Well, they say triangle AHF. Triangle AHF is AHF over triangle ACD over triangle ACD. So if you look at these triangles, they are sharing an angle. I can easily use the area rule that goes with the trigonometric ratio. So this is equals to half AB sine C. In triangle AHF, that would be 45 times 40 times sine of angle A divided by half times in the other triangle, triangle ACD, the whole length, the length AC is 72 by 2, which is 144, that is 144 times the other length is 40 plus 24 is 64 times sine of angle A. Now sine A divided by sine A is 0, and half is 0. We are left with 45 times 40 divided by 144 times 64, and the answer to that is 25 over 128, and that is the answer. They say give with reasons 3 other angles each equals to x. What they told us, or what they gave us at this moment, is that angle E is x. So we need to find 3 other angles that are equals to x. Remember, they told us ABC is a tangent. Therefore, if you look at angle B4 is equals to angle E, that is tan chord theorem. So I'll write the answers up here. 10.1, angle B4 is equals to x, and the reason is tan chord. What is the other angle? We are also told that the line BD is parallel to AO. Therefore, angle B4 corresponds with angle A. Therefore, the other angle is angle A is also equals to x. These are corresponding angles. Why? Because the line BD is parallel to the line AO. The third angle, so we also know that A is x. But when you look at triangle BOE, that is an isosceles triangle because BO is equals to OE. That is the radius of the circle. 10.2, they say determine the size of angle CBE in terms of x. We're looking for the size of angle CBE in terms of x. Now, if you look at angle DBE, so you say angle DBE is equals to 90 degrees. This is an angle in semicircle. Angle in semicircle is equals to 90 degrees. It is subtended by the diameter DE. But the angle that they are asking us, it is the whole this angle CBE, and we know that angle B4 is x. Therefore, this angle CBE is equals to 90 plus x. So that is the angle. Now let's go and look at question 10.3.1. The first question requires that we prove that triangle CBD, it is similar to triangle CEB. So these are the two triangles. So in these triangles, we can see that angle C is a common angle. What other angle is equal? We also know that angle B4 is equals to angle E. They both equals to angle X. This was proven in the previous question. Therefore, the third angle is equal. Therefore, angle D2 is equals to angle CBE. Angle D2 is equal to angle CBE. These are angles of a triangle. They add up to 180 degrees. And that we have proved that these two triangles are similar. With what reason? This is triangle CBD is similar to triangle CEB, and the reason is angle. Those two triangles, they are similar because they are equiangle. Now, let us look at question 10.3.2. They say 2EF times CB is equals to CE times BD. So what you do is that just go and look at those similar triangles. Remember, you must make sure that the way you write the triangle, corresponding angles are aligned correctly. So looking at the expression there, we have CE times BD. So I have a cross multiplication there for which either CE or BD was the denominator. So I'm going back there. I see CB and BD. From the first triangle, I'll write the ratio of CB over BD. This is equals to CE over EB. So I say CB over BD is equals to CE over EB. So this is coming from those similar triangles. And when you cross multiply, you now have CB times EB is equals to CE times BD. Now, using proportionality theorem or using the midpoint theorem, one of those will be able to tell you that the point F is the midpoint of BE. If I use the midpoint theorem, I know that OD is equals to OE, radii of the circle. Now, if those are the radii of the circle, they are equal, and the line OA is parallel to BD. So the converse of the midpoint theorem says a line through the midpoint of a side of a triangle parallel to the other, it bisects the third side. Therefore, this side will be equal to BF is equals to FE. Or you can use proportionality. It will still show you that FE is equals to BE. So instead of BE, I'm going to rewrite BE as BE is the same as BF plus FE, but BF is equals to FE. So this is CB times 2 FE is equals to CE times BD. Now, let us go and look at the last question, which is question 10.3.3. Now, how do you deal with this kind of a problem? Just look at the names that they used. Well, 2EF, you know 2EF represent BE. That is from the previous question. BE, we replaced BE with 2EF, right? Let me just write the answer here. We said this is CB times 2EF is equals to CE times BD. This was our final expression. So we're saying in 10.3.3, it says 2EF over CE is equals to AO over AC. So let's go back to the diagram and identify those lengths that are marked in this expression. So we are solving 10.3.3. When I look at the diagram, AO, it is this line here. CE, it is the longer length going down here. AC is this line going there. And CE, I marked it. AC, I marked it. And AO, I also marked it. Now I said 2EF represent BE. So basically, we are looking at the following triangles. We are looking at triangle CBE and triangle AOC. Now, let us prove if these two triangles are similar. One, we can already see that angle C is common. Now, which other angles are equal? We also know that angle A is equal to angle E. They both equal to angle X. it was proven in the previous question. Now, that means the third side is also equal. So the third angle is also equal. And that angle is angle AOC is equals to angle EBC. These are angles of a triangle are supplementary. So these two triangles, they are similar. So let us write them in correct order. Triangle CBE, it is similar to triangle COA. This is angle, angle, angle. And then let's go identify those lengths. So I see BE here and CE there. So this will be AO over CA. So this is BE over CE is equals to AO over AC. But from the previous question, we know that BE was replaced by 2EF. So this is equals to 2EF over CE is equals to AO over